Okay, we're going to have a look for the time being then about where carbohydrates and enzymes get a lovey-dovey reaction together. But a little bit of simple carbohydrate biochemistry to start off with, and you'll notice an attempt at some modelling. Not me, but the models over here. Okay, we're going to look at some simple carbohydrates before we look at some more complex ones. We won't be going there too long, but essentially hexose is 6 carbon sugars. Have a sort of formula, C6H12O6, and we're going to look at some classic sugars. Probably the one you're most familiar with is either glucose and or sucrose. Now, sucrose is a disaccharide because it has 2 sugars. It has glucose and it has fructose. And if my model is working, I think the orangey sweets all represent glucose. So we have maltose, you have the glucose and the glucose joined together. You have lactose, another disaccharide, and that's glucose and galactose. So the most common sugars that we will be dealing with in our biochemistry, our digestion, our enzyme work are those really. So nothing is quite simple as you might think. If you test sugar for sugar and your sugar is sucrose, then sucrose is a non-reducing sugar, as opposed to glucose and lactose are reducing sugars, and we'll explain more about that as time goes by and just showing how to undertake those tests and what do they mean. So still continuing our theme of carbohydrates, if you notice that we've got an OSE, an OSE, an OSE, and an OSE in cellulose, until it starts to break down a little bit until we look at glycogen and starch. But starch is a composite of 2 different carbohydrates, 2 different polymers of carbohydrate. The starch that most of us will be familiar with is actually a compound called amylose, and amylose is a long chain of glucose sugars joined together. And if I had thousands of more sweets, then I'd make a great big long chain of amylose. Amylose is a long chain of glucose units joined together. We'll talk in a moment about how that happens, but essentially the starch molecule forms a helix. So we've got a helical structure of lots and 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 lots of, I think you get them measured, there are lots, of thousands and thousands of glucose units. Now when we come to react this with iodine solution, iodine and potassium iodide, then the iodine forms a colour complex within that, and that's what gives us our black colour. Different types of polymers, different types of glucose polymers, maltopectin and cellulose and glycogen form, or cellulose forms great big long strands. Glycogen is a bit sort of jointed, and so is a maltopectin, and they join in different ways compared to this great big long chain here. I don't want to go too much into that, you'll guess by the way I'm babbling a little bit, but we'll talk more about that in some time.